morning, one and all physics students, and welcome to another episode of Finzics. It's Mr. Finn coming at you from neighborly Northville, talking to you today about generators and motors. Remember yesterday, we learned a little bit about Faraday's law, about how moving magnets within coils of wire could produce electric current in those wires. Simply amazing, I know. But there's more. We can use that concept to create electricity where there was none, using moving arms driven by wind or by water or by steam that we create either with nuclear decay or with coal burning. Either way, these are generators that are used to produce current in our society. So today, guys, I'm just going to give you a little demonstration on what a generator looks like, and we'll measure some current from this generator. And I'll close with running the motor for the first time, letting you look at that, and then tomorrow we'll follow up with motors again. Okay? So a couple of things. I'm going to go to the big board first, give you that lowdown on what a generator really does, give you the small demonstration, then leave you with a demonstration of a motor, and then revisit motors again tomorrow. So generators and motors today and tomorrow. Hope you guys are doing okay. Make sure you get to your Google Meets, and let's get started with the big board. Okay, guys, once again, trying to make a complicated topic a little bit more simple for us. Let's look at the basics of how a generator works. We're going to take a moving arm that is some kind of magnetic bar of some kind, like we saw yesterday. We're going to move that arm through a B field. So if we put this bar and we turn it within an established magnetic field, then the magnetic field strength will change. If we wrap loops around that bar, then clearly the magnetic field within those loops will change based on its relative position in the field. That will be called a delta magnetic field, a changing magnetic field. The delta means changing. That produces current. Simple as that. We just need to move the arm within the field and somehow get current to be produced. That's what a generator is. All generators work on that exact principle. So let me show you what I have here today in our lab. Okay, guys, what you're looking at here is a St. Louis motor. Whoops, there's my bar magnet falling out. St. Louis motor has this bar right through the middle, and these coils wrapped around the bar. Now you notice that there's plastic in between. Okay, those are plastic as an insulator. Now these coils are wrapped around that bar. Oops, and you can see that these coils are somehow connected to these metal plates on this spindle. Spins around. See, on the spindle itself, there's areas where it's metal, and then there's areas where the metal stops and it becomes plastic. I don't know if you can see that very well. So the metal stops. So one of these metal pieces connected to this brush when it's touching. At that time, the other metal plate on the other side of the spindle is connected with the other brush. These are the brushes of the motor. Now what I'm going to do is I'm going to put these magnets back in here. There was one magnet on this side and one magnet on this side. And that created a magnetic field right across this area. So when I turn this bar, these loops will be exposed to this magnetic field differently if it's here than if it's here. Okay, so that's just, and then of course I'm going to take these wires and hook them up to my meter, which you see is reading 0 right now. All right, so let's see if I can do this right. I'm going to put it together here. So I'm going to put my magnet with the north pole facing this side. I'm going to run this through with the south end facing this side. So right now I have a magnetic field going from the north to the south. Right here. Magnetic field going that way. So Nothing's happening, obviously, because the other part of this wire is not attached to the other end. I have no connection here. But you can see that the magnetic field is still working, but it's just a magnetic field. And if I spin this, I don't know if you can see that there's nothing on the meter. The meter means nothing. Now, when I connect this wire, okay, now these brushes go up through, connected through here, run through here, and back throughout. So this wire runs back through here, goes to the meter, and runs through here. So now I have a bar sitting in a magnetic field, but yet I still read 0 on my meter. Now if I turn it, did you see that? 31 milliamps, 40 milliamps. If I spin this, I'm actually going to read current on the meter. I'm manually spinning. Well, what if I didn't have a manual? What if I wasn't here to turn this bar? Well, then there would be no current. I would have to have something continuously turn the bar, like if I had a running stream of water, or if I had wind turn this. Then I could read current on my meter. That current is not very much. Obviously, we're only in the order of milliamps, but still, you get the idea that a moving arm can create current in the meter. Now, obviously, the established exterior magnetic field is constant, but when I move the coils around this area here, it's moving in a circle, that the field strength within the coils changes. Obviously, if it's here, we have very little. Here we have a lot because the coils are right along with the magnetic field strength. It's going right through the middle of them. Well, that's it, guys. That's what a generator is. Now, let me see if I can hook it up and run a motor for you. Okay, guys, now this is a little dicey, but I'm going to try it anyway. I'm going to turn my motor power supply on. And you see the little red button indicates that there's power. I have this set to 6 or 7.5 volts. I can't tell which one it is. And I'm going to hook these up to here. At the same time, I'm going to turn this. If I can get it to run here. Almost. Come on. Doesn't want to run right now. It's not wanting to run. I had it running a minute ago. What I'm doing is just playing around with the tension of the brush. Here we go. Oh. Playing around with the tension of the brushes for a second. There it is, guys. You see that? It was running by itself for a second, but the tension of the brushes is very critical. Let's see if I can get you guys to see some sparks. There it is. Hopefully you can see those sparks going right there between the brush and the plate. Now, if I had a meter hooked up, I could actually measure how much current was running through those wires right there. But you can see that the power of the supply is running into the brushes down through into the plates. Now, this plate is wrapped around this coil, and then that coil goes to this coil and finally wraps up to the other brush. So we are getting a complete circuit. That's how a motor works, guys. Now, we'll discuss more of that tomorrow. Let's wrap up today. Okay, guys. So, to review a generator today, what I really have to do is I have to manually supply the movement of this arm or this magnet. Really, essentially, it's just the interaction of two magnets. One that has coils wrapped around it. The other is the exterior field. And you'll see in tomorrow's video, those are called stators. Okay, then we move that magnet within the established magnetic field. And of course, the magnetic strength within the loops is now changing. So it's the same thing as plunging a magnet in and out of a coil of wire. According to Faraday's law, voltage would be produced. We can use that voltage to drive anything we want. So generators are all on the opposite sides of those cross-country power lines. Every time you plug into a wall, you're plugging into a generator, or a generator supplying the power that goes to that outlet. It's pretty fantastic, guys. Obviously, there's some really, really interesting questions that we should probably talk about, but I want you to get started on those homework questions if you can. Generators, motors, Faraday's law. Now, I only demoed a motor for you today. Tomorrow we'll talk about just how that motor actually works, and I've got a very interesting video for you tomorrow, and I'll, of course, walk you through it just a little bit. Okay, guys, have a great day today, and we'll see you at the Google Meets.